Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly subscribe, share, like, and comment for more interesting videos and updates. We are still considering calculus as a course. Do you get it that way? So, in calculus, specifically under limits, if you are new here, kindly visit my previous lectures on introduction to limits of functions. Now, you can evaluate limits of function using simple direct substitution, right? Where you'll be given the value of x. Let's say x approaches 2. Then you just substitute the value into the function, right? But at times, you will also encounter questions involving limits, and that will be very, very cumbersome too. So using the sandwich or the squeeze theorem, we'll be able to evaluate those limits with ease. Okay, now, what is the concept behind the squeeze or the sandwich? So what is the concept behind the squeeze theorem or the sandwich theorem? Okay. So now for the sandwich theorem, let us consider the rectangular coordinate system. Okay. So if you have your function this way, then you have this graph to be f of x. Then you have another function this way. You have something like this. Then let's call this h of x. Then you have the third function, and the function lies in the middle this way. So in other words, this touches this. It's not drawn to scale. Pardon me for that. Have it this way. So this is your h of x. Now, there is another function that is sandwiched between these two functions. So let's call the function that is sandwiched between these two functions to be g of x this way. So you have this function which is h of x, and you have this function which is f of x, and you have a middle function which is g of this x function now, which is also equal to another value called L. Now the middle function will assume those values. Do you get that? Yes. So that is the concept behind this. So I will throw more light on this by appreciating examples, that's questions to appreciate this. And now we can also apply the concept of squeeze theorem when you are dealing with oscillating functions. Remember this, oscillating functions. What do we mean by oscillating functions? We are talking about the sine functions and have what? The cos functions. Do you get it that way? Yes. So whenever you encounter functions that way, you can quickly consult squeeze theorem. So in other words, you realize the middle function is being squeezed. Do you get it that way? Squeezed between this and that. It's like you have bread. Do you get it that way? So you have your bread this way, then in between it, when you cut through the bread, then you fix or you place a fried egg inside, right? Then you close it this way. So we say that the fried egg is what? A sandwich between the upper and the lower. Do you get it that way? Yeah, that is the concept behind that. So whenever you have the squeeze story, just send your mind to that of bread. Okay, where the fried egg, okay, inside the middle. So this g of x represents the fried egg. This represents the upper and the lower part of what? Of the bread. That is the whole concept under squeeze theorem or the sandwich theorem. Have you seen how interesting mathematics is? Now, differential equation or calculus is the world. So far as engineering and science is concerned, physics, do you get it that way? Biology, chemistry is concerned, you cannot do away with calculus. All right? Okay. So let's use this concept to appreciate examples. Okay. So mathematically, okay, this is the geometric analysis or the idea of the squeeze theorem. Now let's work or let's speak in the language, okay, which is the mathematics language. Now, if you have a function of, say, f of x, right? So if I have f of x this way, which is less than or equal to the middle function, which is what? My g of x, which is less than or equal to h of what? Of x. Now, when I take the limit, okay, so let me take limits. So we have lim as x approaches, let's say, a certain value, a of f of x less than or equal to g of x. So less than or equal to the lim as x approaches that value a of g of x less than or equal to lim as x approaches a of h of x. Now, by squeeze theorem, what are we supposed to do? Remember, we said when you evaluate this and you have a value of, say, L, which is less than or equal to the middle function we are looking for, which is lim as x approaches a certain value a of g of x less than or equal to. When you evaluate this, and let's say you have L, now by the squeeze theorem, the limit of the middle function we are looking for is equal to any of the other limit. Okay, that's the output of the limit. So L and L, are they not the same? They are the same, right? So in other words, when this function is equal to this function, okay, the value you get is equal to what? The limit of the middle function. That is the whole concept of squeeze or sandwich theorem. So by squeeze theorem, we can say that then lim as x approaches a of g of x is equal to L. As simple as that. Viewers, have you seen how simple and exciting squeeze theorem can be? All right, let's start the business by considering questions. So viewers, on the board, we have evaluate the following. Number one, remember, one hint is this. You have a sine function. So remember, oscillating functions, right? So functions of this nature, right? See the oscillation in that regard. And the same too applies to what? The cos what? Function. So this is the cos function. This is what? The sine function. Now let me tell you one special thing about these functions. Now, the sine function can take values between -1 and +1. You can confirm that using your calculator. All the values you get, okay, so far as these functions are concerned, sine and cos or what have you, all right, the values they are always between this range. So you can write this as a mathematical statement. So you can say you have -1 less than or equal to, let's say, a given function. Let's say you are considering the sine function, right? So let's say sine x, then less than or equal to what? 1. In other words, whatever values you get over here is between this and this. So in other words, these oscillating functions are bounded. They are bounded, right? So when you consider this question like this, you have x to the power 6 multiplying this. So you realize that x to the power 6 is just a simple polynomial functions. And polynomial functions, they have their exponent to positive infinity, to infinity, right? But with respect or with regards to this function, the sine function, it is what? It is bounded. You are restricted. Do you get it that way? So you have -1 and +1, but for functions this way, they are polynomial functions, and you don't have any restrictions or you don't have any what? Any boundary or bounds. So we are going to employ this same analogy. So this also works for cos as well as what? The sine functions. Viewers, So let us evaluate this limit. Okay, so let us consult our squeeze theorem or the sandwich theorem. Now, remember whenever you have a sine function, right? So we know that -1 is less than or equal to the sine function this way, less than or equal to what? +1. It's bounded, right? But we also have sine 5 over x. Okay, so whether you have sine x, sine 4x, sine what have you over here, okay, it still holds. Okay, sine function is just constant. Is that also? So this is just the same as you having your -1 less than or equal to the same sine function, which is what? 5 over 6 less than or equal to 1. Now, viewers, let's work out for something over here. You have sine 5 over 6, over x over here. So you see they are the same. Is that not so? Now, what is missing over here? If you compare this to this, what is missing over here? You realize that x to the power 6 is missing over here. So we can do justice over here, right? So what do? You multiply through. So you multiply through by what? X to the power 6, so that this can assume the question. So when you have this, what do we have? We have x to the power 6 multiplying what? -1 this way. You have less than or equal to x to the power 6 multiplies this. So I have x to the power 6 times sine, then 5 over x. Then less than or equal to x to the power 6 multiplies what? 1 over here. So we multiply this, what do we have? We have negative x to the power 6 less than or equal to what? X to the power 6 sine, then 5 over x. Then less than or equal to then x to the power 6. Is that also? Viewers, now what can we do over here? Think of it. Just think about the whole situation. I'm giving you 3 seconds. All right, we can't do anything here, right? So we can now apply limits, okay, across the functions, right? So applying limits, so we have lim as x approaches a, right? But here our a is what? Is 0 of negative x to the power 6 less than or equal to lim as x approaches 0 of x to the power 6, then sine, then 5 over x. Then less than or equal to limit of the function as x approaches 0 of x to the power 6. Now, we will use direct substitution for this and direct substitution for that. So when you plug 0 into this, what do you have? You simply have 0. Then less than or equal to. Viewers, when you get here, we don't evaluate this. Why? Why? Because this is the question. So from the question, you have lim as x approaches 0 over here. Is that also x to the power 6 over here, then sine of the function being equal, right? So we are not going to throw more light on that because that is the question, all right? So we maintain that to have lim as x approaches 0, then x to the power 6, then sine of the function 5 over x, then less than or equal to, by direct substitution, this becomes what? 0. Now, do you remember what happens? So since the left hand side of this limit, okay, is equal to the right hand side, okay, the far ends, since they have the same value, then by the squeeze theorem, by the squeeze theorem or the sandwich theorem, what do you have? You can say the limit of the middle function x to the power 6, then sine, then 5 over x is equal to what? 0. As simple as that. Using the same concept, let's solve the second question. And the second question reads, okay, let us consider the second question. So evaluate lim as x approaches 0 of x sine theta, right? So we already know that the intervals, okay, the values that will make the sine function define, okay, those are the set of real values between what? -1 and what? And +1, right? So we have -1 less than or equal to sine x less than or equal to +1, right? So comparing this and that, what is missing? We don't have x over here, right? But here you see the coefficient of sine x is x. Here the coefficient of sine x is 1. So we can adjust this equation. So if you multiply 2 by x, so multiplying 2 by x, we have -1 times x, okay? Then less than or equal to, then x times sine x. Then less than or equal to 1 times x. So I have -x less than or equal to x sine x less than or equal to x. Is that not so? So they are the same. So we can now take limits. So we have limit as x approaches, we're giving the value to be 0, then -x less than or equal to x. Lim as x approaches 0, then we have x, then sine x. Then less than or equal to lim as x approaches 0 of this x. So using the direct substitution, you have, when you plug 0 into this, you have 0 less than or equal to lim x as the lim as x approaches 0 of x sine x. I didn't substitute anything here because this is the question, right? Yes. So less than or equal to, by direct substitution, you have 0. So since this and that are the same, then that is equal to the limit of the middle function you are looking for by squeeze theorem. So by squeeze theorem, we know that lim as x approaches 0 of x sine x is equal to L, where L equals what? 0. As simple as that. The third question reads, given that 5x plus 2 less than or equal to f of x less than or equal to x squared plus 8. So we should find lim of f of x as x approaches 2. That's what we are looking for. So viewers, we will not adjust the equation because this function is equal to this function. So we don't need to manipulate the equation again, right? Unlike the others. So we can simply do this. You take limits. So you have limit as x approaches 2 of 5x then plus 2 less than or equal to then lim as x approaches 2 then of f of x then less than or equal to then lim as x approaches 2 then of x squared plus 8. So by direct substitution, when we put 2 over here into x, we have 5 multiplying 2, then plus 2. Wherever you see x, we put 2 there. Then less than or equal to lim, because that is the question, so we don't need to evaluate this. Then less than or equal to, by direct substitution, right? Wherever you see x, you put 2 there. So I have 2 squared plus 8. So what do we have for this? So 5, 2, 10 plus 2. Then less than or equal to lim as x approaches 2, then of f of x less than or equal to 4 plus 8. So we have it to be 12 less than or equal to lim as x approaches 2 of f of x less than or equal to what? 12. So by the sandwich theorem, the limit we are looking for, lim as x approaches to f of x is equal to L, which is equal to 12. As simple as that. So it doesn't necessarily mean you will always be giving x where x approaches 0. All right, so that is all. And the last question to end this tutorials on squeeze theorem is this. Okay, let's consider the last question. Evaluate lim as x approaches 0 of the expression x squared times exponential sine 1 over x. So we already know the values that will make the sine function defined, right? -1 less than or equal to sine what? 1 over x less than or equal to +1. Same for cos function, all right? But for tan function, that wouldn't hold because you get what? Undefined, right? Okay. So here, viewers, what can we do to this in order to get this? So we have sine of the expression this, sine of this, right? So we can raise this to a certain power. Is that also because you realize that this this is acting as the exponent. So we can also make this one to behave like what? An exponent, right? So exponential or e to the power this. So we say that we have e then raised to the power -1 less than or equal to, then the same applies here. You see, you have e here, so you have e then to the power this sine 1 over x. Okay, because it's applicable to this, it has to, the same concept what goes for this and that. Less than or equal to, then you also raise these to the power what? 1. So we have this, right? What is missing? X is missing, right? So we can still multiply the equation by what? X to the power 2 in order to assume this. So multiplying 2 by x to the power 2, so I have x to the power 2 multiplying e to the power -1 less than or equal to x to the power 2, then e to the power sine 1 over x, then less than or equal to, then x squared times e to the power 1, right? Now then, so I did the same x squared exponential sine 1 over x exponential sine 1 over x, right? So we can take limits. So you have limit of the function as x approaches 0 of x squared times exponential -1 less than or equal to the lim as x approaches 0 of x squared exponential sine 1 over x less than or equal to the lim as x approaches 0 of x squared then e. As simple as that. Viewers, don't worry yourself here. But when you put x is equal to 0 into this, right, you simply get 0. Then, because 0 squared is 0, right? Less than or equal to the question itself, which is lim as x approaches 0 of x squared exponential sine then 1 over x. Then less than or equal to the same. When you put 0 here, 0 squared is just 0. So 0 multiplies, you still get 0, so 0. So by squeeze, theorem, and say that lim as x approaches 0 of x squared then exponential sine 1 over x is equal to L, which is equal to 0. Viewers, this is the end to the squeeze theorem or the sandwich theorem. Make sure to subscribe, like, comment, and share for more interesting videos and updates. Click on the subscription or the bell button to subscribe. See you next time. Bye.